Hey everyone, today we'll be going over the Blind 75 in TypeScript, and today we'll be focusing on find minimum in rotated sorted array, and without any further hesitation, let's get started. Hello everyone, today we'll be going over the Blind 75 today, and today we're focusing on find minimum in rotated sorted array. Now, before we get started, make sure we write out all of our 4 questions. We first need to ask ourselves what the input's going to be, what data structure / algorithm to use, what to do with the data, and finally what our output's going to be. Now, to go over the question, suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the array nums is equal to 0, 1, 2, 4, 5, 6, 7 might become 4, 5, 6, 7, 0, 1, 2 if it was rotated 4 times. And 0, 1, 2, 4, 5, 6, 7 if it was rotated 7 times. Notice that rotating an array where we have a given number at a specified index, index 0, a 1, a 2, 0, 1, 2, but really it's just focusing on the index. So it's the same thing as before, 0, 1, 2, because arrays typically start off at 0, and then this is why we have the notation n minus 1, where 1, so if we notice that rotating an array at least 1 times, it's going to result in the following. We have our index here already going from last to first, and accordingly, the rest of the array is going to go up in said fashion, and so on and so forth. So it's taking the last element at this specified index, putting it directly to the front, and therefore it's rotated at least once. And given the sorted array nums of unique elements, return the minimum element of this array. You must write an algorithm that runs an O log n time. So to be able to kick things off, overall, we first need to specify what our input's going to be, and it looks like we have an array colon nums that's specified in the parameters as well. And what we need to return is that even looking at the example, the array, and our output, we need to return the minimum number inside of our array. Let's make sure it's all right. And the data structure / algorithmic technique we're going to be doing is called binary search, where specifically we are going to compare a mid element with the rightmost. To narrow down where the rotation / minimum lies. And so what we are going to be doing is that we will need to, we're going to first initialize our left and right sides. So that means it's going to be left is going to be equal to 0, and then right is also going to be nums.length minus 1, doing the same thing that we did over here. So over here, yeah, so it's going to be in this fashion that we have already set up in this place. And so what we're going to be doing is that we're going to be using a while loop. While left is less than right, we're going to find the mid in the array based on the index. But really, all we got to do is that we have the left-hand side and we got the right-hand side, and we're just going to chop it down the middle. So by dividing by 2, and then compare if nums at the specified midpoint is greater than the nums on the right. That means we are going to have to keep going right until we've already specified on the left-hand side in particular. Left is going to be mid plus 1 accordingly. Otherwise, which will be else, we're going to go left, and we'll have equal to mid. So to be able to kick things off, in particular, we'll have let left equal 0, let right equal nums.length minus 1. Then while left is less than right, And what we'll be doing is that we're going to initialize our mid, math.floor, left plus right divided by 2 as initialized, and then if nums of mid is greater than nums of right, therefore what we're going to be doing, we're going to set this accordingly, else right equal mid, and then we just need to return nums at the very leftmost side to get our minimum. And so let's run this and make sure it's all set up in place. All right, passes all the test cases accordingly. Let's submit. And it checks out. So overall, the time and space complexity for our following solution is that the time complexity as specified in the problem for what we need is going to be O log of n. And the reason being is because we are doing binary search. We are looking on the left-hand side, and also, well, we're looking mostly on the rightmost side first, as well as the left, to be able to find the middle. So it's just based on the given size of the array and how we are already searching. Well, the space complexity, on the other hand, is O of 1 because we're not storing anything and we're just searching for a specific value. So that said specific value is what we're returning, because we are returning just one minimum value. And so yes, this was find the minimum in the rotated sorted array. Thank you very much for taking time to watch this. If you found this video helpful, be sure to feel free to please like and subscribe. And if you have any other questions as well, please leave it in the comment section. And as always, take care. Cheers. Bye-bye.